Hello and welcome to Polynomials 1.3 and Behavior in Factored Form. Okay, so today we're going to still continue our study, our introduction of polynomial functions, and we're going to look at end behavior again, except this time we're going to study what happens when we're given the function in what is called factored form. Yeah, in the previous lesson, we were given the polynomial function in standard form. Yeah, so today we're going to study what happens when we're given the polynomial function in factored form. So you can kind of see it right here in example 1. Yeah, so 5 times the quantity x minus, or x plus 1 times the quantity x minus 4 times the quantity x minus 2. This is what you call factored form. Okay, so we're going to see how do we still get the degree? How do we still get the leading coefficient? Yeah, how do we still get the y-intercept? Yeah, how do we still get all those pieces of information? Yeah, if we're given a totally different looking form of a polynomial function. Okay, so what the degree and LC are, that doesn't change. What they control in the graph, that doesn't change. It's just how we acquire the information is going to be a little different from what we did in the previous lessons. Okay, so when we're given factored form, it makes certain things easier. It makes certain other things more difficult. So it's going to actually make the degree and LC a little bit more difficult. We're not just going to be able to just look at the biggest power and say, oh, there it is. There's my degree. Yeah, we're not going to just be able to circle what term has the biggest degree or the biggest power and say, there's my LC. It's not going to be that easy. Okay, so other things are going to be easier though. So it's a give and take, right? You can't have everything good in one problem and just be happy that way. Okay, so let's get to our first problem and let's see how to find degree in LC. Okay, so degree is kind of not that bad, yeah, in these problems. LC is a different story, but degree is actually not that bad. It basically involves something you've been doing ever since you were a little baby, counting, right? You counted fingers, you counted how many gummy bears you get to eat, you count whatever, you count Pokemon cards or whatever you used to collect, right? Degree is all about counting, okay? So to get to your degree, you just got to count how many x's are in your factored form. So let's do a little count. So we have 1, 2, 3. So you have 3 x's. So there's your degree, 3. Well, actually, let's get the pen mode. Okay, so 3 is your degree, and 3. So I'm gonna just, like I said, I'm gonna preach this to you so that you guys get into the habit. So don't just write 3 on the line. Write what 3 is, which is a odd number, and it is going to imply opposite arrow behavior. Okay, so you want to kind of write these things also on this line. Yeah, I'm not going to require it. Well, actually, no, maybe yeah, I am going to require it later on, but I'm not going to require it here. But you should get into the habit of doing it already. Yeah, but later on, it's going to be required to write odd and opposite in later on lessons. Okay, so LC. So this is going to be the one that's a little bit more humbug. Okay, so LC is going to be where you grab all the coefficients, right? Because that's what LC stands for, leading coefficient. And coefficient are your numbers that are in front of each x. Okay, so if you look at all of these x's, what number is sitting right in front of all of these x's? So there's a 1 right in front of that x, there's a 1 right in front of this x, and there's a 1 right in front of that x. Okay, and your leading coefficient is going to be the result of multiplying all those blue numbers that I just wrote together. So what is 1 times 1 times 1? And hopefully you say to yourself, 1. But I'm going to make sure you do this though. Don't just write a 1, write positive 1. And you're probably going to say, why do you want me to write positive 1? Isn't a 1 implied that it's positive? And I'm not going to remind you about this. Yeah? From what we saw in the first couple of lessons, does the LC care about the number? It eventually does, but for right now, does the LC care about the number? No, LC only cares about the sign, right? Because whether your LC is positive or whether your LC is negative, it's going to control the direction of the right side arrow. So like I said, okay, the number is important. It eventually makes a big difference later on. Yeah, but for right now, as far as what we're studying right now, we care about the sign. And that's why I said, yeah, I know 1, if you just write a 1, it's going to imply that it's positive, but I'm going to ask you to put the positive sign there anyway, because it reminds you that the LC cares about the sign, more so than the number, for now. Okay, so A positive LC implies your right side arrow, your right side arrow is going to go up. Okay, so please get into the habit of making these associations and write the words opposite odd, right up. All right, so x-intercept. Okay, we never asked you to do x-intercept so far in this topic yet. We asked you how to do x-intercept in other quadratic function lessons, but we didn't ask you to do it here yet. Okay, so how do we do x-intercept? Well, it's going to be the same exact way we did x-intercept if it was a quadratic function. We're going to grab each parentheses, so x minus 2, x plus 5, x plus 3, and we're going to figure out what makes each parentheses turn into a 0. And the number that we use to turn each parentheses into a 0, that's going to be the location of my x-intercept. So x minus 2, what number can I put in place of x so that when it interacts with negative 2, it becomes a 0? Right? So you got x minus 2. What number can I put in place of x so that when it interacts with negative 2, it cancels it out? So hopefully in your brain, you say to yourself, oh, I think I know what that is. That's 2. So there's your first intercept coordinate, x-intercept coordinate, 2, 0. So what number can you plug in place for x in the next parentheses that's going to cancel out a positive 5? And hopefully in your brain you're saying, oh, I think negative 5 does that. And if you said that, that's perfectly correct. And in your last parentheses, you're going, whoa, wait. This guy has 3 x-intercepts? Yeah, we're not dealing with quadratics anymore. We're dealing with polynomial functions. Yeah, you can have a whole bunch of x-intercepts. There's no rule that says you can only have 2 anymore. Yeah, that's quadratics rule. You can have a lot of x-intercepts in polynomial functions. So this guy has 3 of them because we have 3 x's. Yeah, so what's going to cancel out a positive 3? Negative 3. Okay, all right, so y-intercept, that's not that bad because hopefully you remember that y-intercept, you're going to plug in the easiest number ever in the entire world, which is a 0. So basically you're going to go 0 minus 2, and you're going to go 0 plus 5, and you're going to have 0 plus 3. So basically it's negative 2 times 5 times 3. And what is negative 2 times 5 times negative 3? Wait, did I say it wrong? Negative 2 times 5 times 3. And hopefully you say negative 30. And if you said that, well, you just found your y-intercept coordinate. 0, negative 30. Okay? All right, let's look at B. Okay, so degree, let's count our x's. So 1 x right here, 2 x's, 3 x's, 4 x's. Whoa. Why did I count this x twice? Right, I went 1, 2, 3, 4. Why does this guy get counted twice? Did I do this wrong? And no, I didn't, because if you look at the equation, there's a little 2 at the very end, implying that I have negative 2x plus 7 written twice. So that's why I counted this x twice, because he has a power of 2 at the very end. So this guy's degree 4. So that's going to mean this is an even number, and it's going to imply same direction for arrows. Okay, so LC. Let's grab all my numbers in front of the x's. So I got a 5. Yeah, I mean, I'm writing it down because that's what I did last time. Yeah, you can clearly see there's a 5 there, but I'm going to write it down anyway because it's going to help out later on. Yeah, I see a 3 in front of this x. I see a negative 2 in front of this x. And then I see a negative 2 in front of the other x, because there's 2 negative 2x plus 7's written, right? So I write negative 2 twice. So as far as LC is concerned, we're going to go 5 times 3 times negative 2 times negative 2, and that's going to give me positive 60. So my LC is positive, so that means my right side is, what is it, guys? Up or down? Hopefully you say up, okay? Because it's a positive LC. Yeah, and that's what I said, right? Even if you know 60 is positive, we're going to write the positive sign anyway, because it's going to remind us that LC is positive, and that means right side arrow is up. Okay, so x-intercept, we're going to figure out what makes each of our parentheses 0. So 3x minus 2. Okay, so this one's a little bit more difficult because you can't just say, oh, I'm going to put a 2, and 2 minus 2 is 0. Yeah, that 3 that's in the very front is going to mess things up. So I taught you guys to do it this way. So you're gonna grab the entire parentheses, you're gonna set it equal to 0, and you're gonna solve for x. So 3x minus 2 equals 0 turns into 3x equals 2 because you're gonna add 2 on both sides. Then you're gonna divide by 3, and you're gonna get x equals 2/3. So 2/3 comma 0. Okay, so what about our next one? Negative 2x plus 7. So let's set that guy equal to 0. Negative 2x plus 7 equals 0. So you get negative 2x equals negative 7 because you're going to subtract 7 on both sides. Divide by negative 2, divide by negative 2. So you get x equals 7 over 2. Or you can call that 3 1/2. Okay, so I got my second coordinate, 3 1/2, comma 0. Okay, and we got one more. Because I forgot to look at one of my x's. And you're saying, oh yeah, we forgot to look at the negative 2x plus 7 again. No, that's not the one I forgot. We already have that x-intercept. It's 3 1/2 comma 0. We forgot to look at the x that's in the very, very front. And the reason why a lot of kids forget about this guy is because he's not in parentheses. Yeah? So people often forget about him. So when you just see a regular plain old x in the front, or in the middle, or in the back, wherever they decide to put it, right? If you just see a regular plain old x that doesn't have x plus 5, or x minus 3, or x plus 7, or anything x plus or minus anything, and it's just plain old regular x. I mean, I know it has a 5 in the front, but that's not going to make a difference. Yeah, it's just regular plain old x. Yeah, how do I turn regular plain old x into a 0? And you're thinking, is that a trick question? How do I turn an x into a 0? Well, I just plug in 0, don't I? Yeah, so to turn this x into a 0, I'm going to plug in 0, and that's going to be the location of my third x-intercept. And then you're going to say, oh, so do all polynomial functions have 3 x-intercepts all the time? And I'm going to say no. It's just a coincidence that these first two problems had 3 x-intercepts for both problems. Sometimes you can have 4, sometimes you can have 5 x-intercepts, sometimes you can have 2 or 1. Yeah, it all depends on the numbers you're given. Okay. All right, so let's look at the y-intercept. We're going to plug in 0. So I kind of need some space. Let me page expand. And the top of the problem is going off the page. So let me do fit to height. There we go. Okay, so let's do this. And we make a little line of separation so you guys can see that this is different from what we had earlier. Okay, but what I do know is my x value is 0. So that's what I'm going to plug in, 0. So I got 5 times 0. Right, because I'm going to put a 0 everywhere I see an x, times 3 times 0 minus 2, times negative 2 times 0 plus 7 squared. Okay, so first let's do this. 5 times 0 is 0. 3 times 0 is 3, or 0 rather, I almost said 3. I kind of did, but I took it back. So 3 times 0 is 0 minus 2. And negative 2 times 0 is 0 plus 7 squared. Again, at this point, you should say to yourself, well, I think I know how this is all going to end. Because hopefully you remember from your elementary school days that if you ever multiply by 0, what is your end result answer always? Right? When you multiply by 0, what is always the answer to a problem that says you're going to multiply by 0? And hopefully you're saying to yourself that the answer is always 0. And it doesn't matter what you multiply with the 0, as long as you multiply by 0, it's going to pretty much make everything else cancel out or disappear, right? So even if I have a 0 minus 2, this guy doesn't care. 0 times 0 minus 2 is 0. And I can have 0 plus 7 squared. This 0 in the very front doesn't care because when I multiply it, it's just going to cancel everything out. It's going to make everything 0. So I can have a string of 100 numbers that I'm all multiplying together. As long as one of my numbers is 0, my entire answer becomes 0. So my y-intercept is 0, 0. Okay? All right, so I think I'm going to do one more problem because there's one more problem that is not in one of these examples that always gives the kids some issues. So I'm going to do problem 1 from your homework, and I'm sorry I'm doing part of your homework again. Yeah, but trust me, you're going to want me to do it. Okay, so we're going to go and count for my degree. So we're going to go 1, 2. So why did I stay on this x twice? Well, because there's a power of 2. So 1, 2, 3. So my degree is 3. And that's going to imply odd number. So opposite behavior. So my arrows are opposite. Okay, so let's look at all my coefficients. So my coefficient here is a 1. My coefficient here is a 1. I'm going to write 1 another time because it says squared. And then here's the one that kids always don't assume is part of your LC, the -5. Because he is also technically in front of the x also. He's not the one that's directly in front of the x. A 1 is directly in front of this x, but -5 is being multiplied to it. So therefore, -5 is part of your LC as well. So -5 times 1 times 1 times 1 makes a -5 for your LC. So that means your LC is negative, so your right side is, and hopefully in your brain you're saying right side is down. Okay? So, x-intercepts, well, we know one guy is -2, 0. So I'm going to go right to left. We know another guy is going to be 1, 0. And then you're going to say, ooh, so is this that situation just like we had in the previous problem where we're going to have 0, 0 also? And I'm going to say no, because do you see an x outside the parentheses next to the -5? No, we don't see an x outside the parentheses next to the -5. The x is inside the parentheses next to a -1, and that's why 1, 0 is an x-intercept. Yeah, there's no regular plain old x on the outside here that's going to make me put 0, 0 as an x-intercept. Okay, it was a part of the previous problem that I just did, but it's not part of this. So this -5, that's why I said it messes up a lot of kids. So make sure you look at this problem and the one that we just came from really carefully side by side so that you can see the difference between what they're causing the numbers to be. Okay, so let's do y-intercept. That means I plug in a 0 for my x, and let's see what happens. So we got -5, and then we have 0 minus 1 squared, and we have 0 plus 2. Okay, so we got -5 times -1 squared, so I'm going to write -1 twice, times 2. So we got -5 times -1 times -1 times, what happened to my parentheses? Times 2. So that makes, what does that make, -10? Yeah, that makes -10. All right, so I believe this is the end of this lesson. I hope everything made sense. If it didn't, just rewatch it. Yeah, that's the video, so you can just rewind, stop, pause, yeah, take a break, do whatever you want to do. Yeah, and I'll see you in class. Bye-bye.